Okay, guys, this is our introduction to the metric system. Um, you've probably maybe used the metric system in biology, maybe your eighth grade science class. Um, all we do in here is use the metric system. So it's really important that you become very familiar with it. So what you guys are used to using is the English system. The English system, as you know, are things like feet, inches, pounds, miles, etc. We're the only country in the entire world that still uses that English system. Now, the metric system came about by the French, and it was meant to be a universal system. So whether or not I'm talking about scientists or chemists in Germany or South America or anywhere, any chemist knows that 10 centimeters is 10 centimeters is 10 centimeters. That's different than if I tell you, for example, an eighth of an inch, okay? This is what we use for our metric system. For length, we're going to be using meters. For mass, gram. For volume, liters. For time, second. I'm going to add to this for pressure. We're going to be using what we call ATMs, which is atmospheric units. And then we'll be using moles, but we'll get into that at a much later date. Now, when we talk about the metric system, we're talking about just, again, a standard way of measurement. So if I'm talking about whether I'm measuring length times width times height, or if I'm measuring water, I can measure water, for example, both by mass, meaning grams, and also in volume. So for example, milliliters. Now, this is your table. I'm going to upload the table. I highly recommend that you print it out and have it handy. The tricky part about this table is reading the table. It's deceiving. A lot of students read this table and say, oh, 1 centimeter is 0.01 meters. No, this table is telling you the value of the unit. Okay, they're telling you the value of whatever that is. So just like we say a penny is 1/100th of a dollar, we would not say 1/100th of a penny is equal to a dollar. So we would not say 0.01 centimeters is equal to 1 meter. I like to think of this line here as the break between decimals and whole numbers. And also, where it says basic unit, the meters, the grams, the liters, the second, that's what I refer to as our parent unit. All right, so what do I mean by this? When I am reading this, I'm going to want to say 1 of whatever it is. Okay, 1 centimeter, 1 millimeter, 1 micrometer. 1 of that thing is equal to this amount of the parent unit. Okay, so for example, I might say 1 centimeter is equal to 0.01 meters. Okay, I might say I'm terrible at writing those, micrometer is equal to 0.000001. meter. Okay, so that's how I read this table. That's going to become very important, especially when we do the metric conversions, which we will spend a class period doing that. So how we abbreviate, we use the parent symbol as the last letter, and the prefix, kilo, milli, micro, giga, etc., as the primary first letter, and they're all lowercase. The other thing I want to let you know, you need to memorize from mega to micro. This is what you're going to have on a test. All right. So when we look at this and unit equations, we need to be able to relate two different things. Just like we say 4 quarters is $1 or 100 pennies is $1 or one single dollar bills is equal to a $5 bill. We're going to do the same thing with the metric system. So when we relate these, we call it a unit equation or a conversion factor or a unit factor. All three of those terms mean the same thing. Okay, now we can say 1 kilometer is 1,000 meters, and we can also say 1 centimeter is 1/100th of a meter. We use this equal sign to relate them. However, we can also relate them in terms of a fraction, and it's this fractional relationship that shows a ratio between the two different units. We like this fractional piece because we're going to be able to do the math and now use it as a conversion factor. So what do I mean by that? Well, when we talk about the fancy word is unit analysis method. Basically, it's just metric conversions. And we got 3 steps of doing this. Figure out what the problem is asking us, set it up appropriately, and use the conversion factor to get from one unit to a different unit. So this is what we're going to have it look like. We are always going to use this setup. We have some given value times a unit factor. It's going to give us our answer. All right. Now, we are just coming off doing math and getting the correct amount of significant digits for our final answer. Well, now we're going to be doing the same thing, but you only figure out how many significant figures you need in your final answer only based on the given information, not on the unit factors. So let's look at a problem. What is the mass in grams of a 325 milligram aspirin tablet? In this problem, this is our given. Okay? They're asking us for grams. We were given milligrams. So for our given, that's what we got right there. Our relationship between them, if you go back to that chart, let's go back real quick. If we look, we were given milligrams and it was asking for grams. So here's milli. We're going to say 1 milligram is equal to this many grams. Okay? So what they have done here is they've switched it up. Basically, we said 1 milligram is equal to 0.001 grams. That's like saying 1 penny is equal to 1/100th of a dollar. Okay? Same thing. That's like saying 1 penny is equal to 1/100th of a dollar bill. They've switched it up in this particular example, and they have said, okay, instead of that, we're going to say 1 gram is equal to 1,000 milligrams. Why can we do that? Well, a lot of the little thing is equal to 1 of the big thing. Doing it this way is kind of like saying $1 is equal to 100 pennies. And that is a terrible dollar sign, y'all. Okay, let's fix that. It's bothering me. So either way you want to do the relationship, it's fine with me. Whatever's easiest for you to understand, either directly follow the chart, saying one of the small thing is equal to the fractional piece of the big thing, this format, or some of you may know 100 centimeters is a meter, or 1,000 millimeters is a meter. You may just know that just from everyday stuff. And, so doing it in this format might be easier for you. Whichever way works easiest for you, I'm fine with, so long as that you keep the correct number with the correct unit. For example, we would not say 1/100th of a penny is equal to $1, right? In the same way, we would not say 0.001 milligrams is equal to 1 gram, or 1,000 grams is equal to 1 milligram. These are things we would not say, okay? Once we have that all set up, we can simply just use the conversion factor here to do the math. So what happens is, you can imagine, I like to put this over 1 so it looks like I'm multiplying two fractions together. And you're going to see in class how I actually write it out. We call it the railroad tracks. So we don't actually separate out the fractions into two different fractions that are multiplied together like you see here. We actually kind of blend them all together, but I'll do many examples of this and you'll see how it works. All right, here's another example. A hospital has 125 deciliters of blood plasma. What is the volume in milliliters? Now, we're given 125 deciliters. They are asking us for milliliters. Now, if you go back and look at that chart, you will see that there's no direct relationship between deciliters and milliliters. But what do these two units have in common? What are the two things that are connecting them, kind of the middleman, if you will? If you said an answer, your answer should have been liters. I can compare deciliters to liters. I have a direct relationship between them for conversion. And I can relate milliliters to liters. There's a direct relationship on that chart between them. So now this is a problem where it's going to be two steps. We're first going to convert, our strategy is going to be to convert deciliters to liters, and then liters to milliliters. That's kind of going to be our roadmap. So here's what it looks like. Again, I like to put this over 1, so it looks like we're multiplying 3 fractions together. Here's fraction 1, fraction 2, fraction 3. And what this does is it allows units to cancel. You can see that deciliters are opposite of each other in the fraction, so they would cancel. Liters are opposite each other, so they will cancel. What I am left with is milliliters, and that's perfect because that's exactly what I want. Now, to mathematically solve this, I like to take the whole top and multiply it together to get an answer. Okay, in this case, it's going to be 1, 2, 5, 1, 2, 3. Okay, and then divide by the whole bottom multiplied together. Okay? The mass of the Earth's moon is 7.35 times 10 to the 22 kilograms. What is the mass expressed in nanograms? Again, 3 things going on here. Here's our given information. and we're given kilograms, it's asking for nanograms. And if you look on that chart, there is no direct relationship between kilograms and nanograms. But they do have one thing in common. That thing they have in common is grams. And so I'm going to go from kilograms to grams and then grams to nanograms. So we're going to go from kilograms to grams and then grams to nanograms. That's going to be our roadmap. This time we have scientific notation, not just a regular number. So it's really important that when you put it into your calculator, you put parentheses around it as you're typing it into your calculator. By the way, please make sure that when you come to class and we're working these problems, that you have your calculator with you. Scientific calculator, just like what you use in math class. Again, I like to put this over 1 because visually it's easier for me. You can see that when we convert from kilograms to grams, here's our relationship. And that'll allow kilograms to cancel. And then nanograms, you'll see here. When you type it in, it should be in your calculator as such. And then grams will cancel. And we're left with this. Okay? Compound units are also something we deal with a lot in chemistry. You've dealt with compound units before. You probably just maybe called them something else, like mph, miles per hour. If you're somebody that likes to work on cars, PSI. You've seen that probably with tires. Pressure per square inch. What's another one that you would do in your everyday life? Oh, if you have a job, your dollars per hour that you earn. Okay? In chemistry, we see it in density. We see it in different constants that we're going to be using, like the ideal gas law constant. We're going to see it in volumes. We're going to see it in lots of other places. If you had miles per hour, and let's say it was 55, I'm actually going to write this 55 miles per 1 hour. Get in the habit of writing these compound units like a fraction. Try not to do this. Try not to write it in this format. Get in the habit of doing it like this, because oftentimes those compound units we'll be using as a conversion factor. So here's a compound conversion problem. We were told a motorcycle is traveling at 105 kilometers per hour. What is the speed in meters per second? If you like to break this up and not do it all at once in a row like you see here, I'm fine with that. Some students like to say, okay, I'm going to do the 105 kilometers per 1 hour, and I'm going to start with the kilometers. And frankly, it doesn't matter if you start with kilometers or if you start with the hours. It doesn't matter which one you start with. I personally like to start with the one that's on top. So I'm going to take this and I'm going to start with meters. Okay, now I want kilometers to cancel, so that will go on the bottom. I want meters, so that will go on top. Doing this allows my kilometers to cancel. Now the question is, what numbers do I put in there? Well, if I go back to my chart, you will see that we will have 1,000 meters is equal to 1 kilometer. So now my number is going to stay with my buddy unit. And I'm going to get 105,000 meters per 1 hour. Now I can go ahead and convert to seconds. If you don't know how many seconds are in an hour, you can go ahead and convert from hours to minutes and then minutes to seconds. But it's a good idea in here just to go ahead and memorize that 1 hour is 3,600 seconds. So I need hours to cancel, and hours are on the bottom. So now I'm going to put hours on the top and seconds on the bottom. Why? Because now this allows hours to cancel. I'm going to keep my number with its buddy unit. And now I'm just going to divide the two numbers to get 29.2 meters per second. Okay, this wraps up this lecture. Make sure when we're working these problems that you do in fact have your calculator.